Hi viewers, welcome to Number Solution. Today we are going to see about speed control of BLDC motor using sliding mode controller. This is a simulation model we developed for speed control of BLDC motor using sliding mode controller. This Simulink model consists of DC source and then 3-phase voltage source inverter and then BLDC motor drive, and then here we have motor parameter, that means measurement of motor parameter like Hall sensor output, speed of the BLDC motor, and then electromagnetic torque. This is a sliding mode controller. The sliding mode controller receive two inputs. One is reference speed, another one is actual speed. After comparison of reference speed with actual speed, we have error voltage and then rate of change of error that will be processed via sliding mode control x1 and x2. Inside this function, we return that the sliding mode surface. This is a surface of the sliding mode controller S, which is equal to x2 plus 200 into absolute value of x1 power 2 multiplied with the sine of x1. So this is a sliding surface for that sliding mode controller. This sliding mode controller generates the modulating signal, or else we can call it as duty cycle. That duty cycle going to be processed via the switching logic circuit of BLDC motor. That modulating signal or duty cycle going to be compared with the triangular wave. So it will be generate the PWM pulse. That PWM pulse going to be ANDed with the Hall sensor output from the BLDC motor. Each ANDed output going to be used for drive the voltage source inverter. So here we are having the 6 pulse. So this 6 pulse going to be drive the voltage source inverter, not to control the speed of the BLDC motor. Here you can see that the get pulse going to be given to this voltage source inverter. Go inside, you have 6 switches. These 6 switches going to be a drive from that switching logic circuit to control the voltage of the BLDC motor in order to control the speed of the BLDC motor. And here we provide the reference voltage. Initially we provide the reference voltage is 1000 rpm. After 0.2 second, the reference speed changed to 1500 rpm. And here we are providing the torque input for BLDC motor. Here we are providing the torque input for BLDC motor is 5 Newton meter. I am going to simulate this model and then I am going to check the result of the speed. Here you can see that this is a variation of the speed. The initial speed we are fixed at 1000 rpm. So here you can see that the speed of the BLDC motor is maintained at 1000 rpm. After 0.2 seconds, we are changing the speed to 1500 rpm. Because of changing reference speed, you can see that the actual speed of the motor changed from 1000 to 1500 rpm without any overshoot. So I am going to zoom this little bit. Here you can see that. So initially we are having the overshoot around 20 rpm, and then I am going to zoom portion, and here when we are operating the machine at 1500 rpm, we are getting the overshoot around 6 rpm. That means 20 divided by 1000 is around 2%. 2% of overshoot, and 6 divided by 1500, that means 0.4% overshoot. We are getting 2% overshoot when we are operating the machine at 1000 rpm. We are getting 0.4% overshoot when we are operating the machine at 1500 rpm. Next, I am going to operate the machine. That means initially I am going to make reference speed equal to 1500 rpm, and then I am going to make the final speed of the machine. That means after 0.2 second, I am going to make the speed of the machine equal to 200 rpm, and then I am going to check the result. Now you can see that initially the speed of the machine reached at 1500 rpm. After 0.2 seconds, the speed of the machine, the reference speed going to be changed from 1500 rpm to 200 rpm. Because of that, the machine comes to 200 rpm. Here we can see the detail. That means that machine speed is maintained at 202 rpm. That means it having error around 2 rpm. And then here you can see that the machine almost maintained at 1500 rpm with overshoot of 0.4%. For a step change, that means step increasing speed reference as well as step decreasing speed reference. The sliding mode control effectively control the BLDC motor speed. And also here you can see that this is the torque of the machine during change of speed reference command, because you can see that it always maintain 5 Newton meter during the disturbance, that be during that reference speed command. The torque of the machine going to be changed in order to balance the power. After that some point it comes to 5 Newton meter. So this is the working of speed control of BLDC motor using sliding mode controller. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you. Thank you so much. Bye bye.